And just like that, it looks like surface mount is done. Now, before we power this board up, let's review the major changes. The big one here is how I'm powering it. The LTC7891 is now the power supply. This is the same one I used in my amplifier a couple of years ago that worked pretty well. The downside is we're going to have to control the voltage a little bit differently. So now I'm actually using a PWM that is highly filtered from the Pico 2 to basically muck with this feedback voltage, and hopefully we'll be able to set this anywhere from 0 to 24 volts or so. I will have to write some firmware for this PWM power supply signal, so I think before we actually power the board on, that should be next. A quick recap of the circuitry that we're going to be testing today. Let's start with the amplifier circuit. We're using the LMG1210, which is designed to drive GAN FETs. A little speed up circuit to help basically keep from frying that gate, but also drive it about as fast as we possibly can. This is going through a little low-pass impedance transform circuit, and then through some filtering, and then of course we have a little test port so we can measure how much power is coming out. Some relays for controlling the signal flow, and that's basically it for the actual transmit power. To actually power that, the LTC7891, like I mentioned before, high side current sense, so we can see how much current we're putting out. The nice thing about this 7891 is it will actually limit the current, so we don't have to worry quite so much about frying our GAN FETs. Little voltage monitor circuit, some bias voltages to make everything a little bit more efficient. And then on the receive side, we have some switches, some filters. We have this little directional coupler, so we can make a little VNA antenna analyzer to help us tune our antenna. And then, of course, the actual amplification, down conversion, filtering. This is that fun little quadrature hybrid circuit that I like. And then the AK5534 for some high dynamic range ADC action with its power supply, low noise power supply, and I guess this is just the additional secondary gain stage. Of course, our trusty Pico 2, we're using the HSTX port to take in a clock from this CDCE6214, just a low cost clock source off of a little TCXO. And then this is going to make our 14 to 14.3 megahertz phase signal, which is going to get filtered and squared up. And then that is going to go back and drive this amplifier input. So that gives us a phase corrected square wave at the desired frequency to drive the whole system. And with the phase here and the amplitude here, we have our polar modulation. The other thing that's kind of cool is we do have a simple little antenna circuit. So the signal comes in here. We can switch between 0, 1, 2, or 3 steps of inductance and 0, 1, 2, 3 steps of capacitance. And it can be either CL or LC, depending on whether or which direction we need to match the impedance.